गुड मॉर्निंग एवरीवन। आवाज आ रही है? सो वेलकम टू यू ऑल ऑन एग्जामपुर आईएएस इंग्लिश मीडियम और we are providing you the crash course for UPSC Prelims 2022, and for that the regular classes is commencing from morning 7 a.m. So join us fast. Already 2 classes has done in which we have completed atmosphere, and in the last class we have finished some portion of insulation, and you can see the factors affecting the temperature we are going to cover today, and we have completed one more point, that's the greenhouse effect. Greenhouse effect was done in the last class. Okay, so Mradul Raj, very warm welcome, brother. Today we are going to discuss the factors controls the temperature, okay, affecting the temperature. Basically, how the some areas of the Earth's surface receives the maximum heat, while some faces the very less amount of heat. Why such kind of phenomena occurs over the Earth's surface? So lots of reason behind it. Okay, आज हम लोग एयर प्रेशर बेल्ट की भी चर्चा करेंगे, and also we will take some portion of the albedo and thermal anomaly, which is very important. Okay, Vivek Kumar, good morning to you all. Come. So today we are going to discuss the first topic, that is the factors affecting temperature distribution. Here you can see the factors affecting temperature distribution. What about the reason behind the differential heating of temperature on Earth's surface? Okay, the first point about the factors affecting temperature distribution, that is the angle of incidence or the inclination of the sun's rays. You can see in between the Tropic of Cancer to Tropic of Capricorn, there is a direct rays of the sun is just overhead the Earth's surface. But when you go beyond it, from equator to poles, the sun rays becomes slant and becomes inclined, and so the sun rays has to cover the maximum distance, and that's why it will releases the heat also. So first point about the factors affecting temperature distribution, the angle of incidence or the inclination of the sun's ray. The first point is the area lying close to the equator. That means the regions which is very close to the equator line gets the maximum heat is just because of the direct rays of the sun or the perpendicular rays of the sun. That's the point here. The area lying close to the equator receive the maximum heat due to the near vertical rays of the sun or direct rays of the sun. You can mention direct rays of the sun or a parallel or a perpendicular rays of the sun. Okay, perpendicular rays of the sun. The second point is what? The sun's rays get progressively slanting as one moves away from the equator towards the poles. What I have said just. Okay, the sun's rays get progressively slanting as one moves away from the equator towards the poles. Like see, you can see this one is the equator line. Here it is Tropic of Cancer. Here it is Tropic of Capricorn, having a 23.5 degree north latitude and 23.5 degree south latitude. Okay, so this is the zone in which the direct rays of the sun can be overhead at the Earth's surface. Only this is the zone. Okay, got it? This is the only zone. After this, progressively you can see the rays become slant towards the poles, North Pole or South Pole. So the second point is this. Third point, as a result, the heat received from the sun decreases as the distance increases from the equator. In thermodynamics laws, you have read already, the heat decreases with increasing distance. Okay, so here it is also, the heat received from the sun decreases as the distance increases from the equator. Next, areas lying close to the poles receive the least of sun's energy as the sun's rays are near horizon. You can see in this picture कि at North Pole region, this is the zone where the sun rays becomes in a almost horizontal manner. And this is the zone where the 6-month days and 6-month night occurs, is just because the earth is tilted on its axis by 23.5 degrees and it revolves around the sun. So that's why beyond the 66.5 degree region, there is a 6-month day and a 6-month night. If in North Hemisphere there is a 6-month day, then the South Hemisphere will face the 6-month night. Why it happens? It happens just because the earth is tilted on its axis. Earth is tilted on its axis and revolves around the sun. That's the main point behind it. Getting a point or not? Mradul, Vivek? Do like and share, brother, also. This class will continue for whole week. Okay, come to the next. Like you can see in this picture, the sunlight strikes most directly in the equatorial region and the low angle of incoming sunlight in the Arctic Circle region and the Antarctic Circle region. So shorter the distance, maximum the heat by the second law of thermodynamics also. Shorter the distance, maximum the heat. Because one more point I want to explain here. Like this one is a surface. If the shorter the distance or a perpendicular rays is coming to the surface, it will spreads on very less areas. Okay, it will spreads on very less areas, while a slant rays or inclined rays is spread on larger areas. And also they have to travel the maximum distance. So this surface will receive least of amount or a very less amount of heat. It's just because the maximum distance this rays has to travel and also it has spread over the larger area. While in the equatorial region, you can see the rays are direct or a perpendicular to the Earth's surface, and also it spreads on very smaller area. So this area will receive maximum heat and this side is receive less amount of heat. Is it clear up? Ronit Raj, welcome bro. So that is all about the factors affecting temperature distribution, and one concept behind it, that the direct rays of the sun, slant rays of the sun. It is, you can see it in this picture also, and also the what I have said, key the slant rays has to travel maximum distance and has to spread over the larger area. So this region will receive the less amount of heat. Receive less amount of heat. Okay, now come to the second point. The second point is duration of sunshine. That means अगर सिंपल समझे कि दिन की अवधि, दिन में ही तो सूरज के प्रकाश की प्राप्ति होती, दिन की अवधि समझ. Duration of sunshine. It also changes with the changing of sun's location. If sun goes northwards, the span of day's time increases in northern hemisphere while sun went to southern hemisphere or southwards. The day's time will increase in southern hemisphere. Okay. So the first point you can see here, heat received depends on day or a night or a length of day or night. Okay, length of day or night. And also it is affected by the cloudless sky or a clear sky. Then you can see the clear sky or a overcast summer or a winter. Simply, the Earth's atmosphere plays an important role in moderating the temperatures between the seasons and between the days and nights. Okay. सिंपली अगर हम लोग समझ ले इसको छोटा सा पॉइंट में कि दिन की अवधि अधिक होगी तो सूरज के प्रकाश की प्राप्ति भी तो अधिक होगी, तो एरिया विल गेट वार्मर एंड मोर वार्मर. Okay. In winter, the days hours is less, so the less amount of heat we receive, so you feel cold in winter season. While in recent scenario you can see we are facing the heat waves. Days hours has increased. The maximum length of days would be on when 21st June. Okay. So this is the duration of sunset. Next, transparency of atmosphere is the next one. Next one is transparency of atmosphere. Aerosols, smoke, soot or pollen. We have already discussed in aerosols or dust particles or solid particles. Dust, water vapor, clouds, etc. affect the transparency of atmosphere. If the clouds covers the sky, how can sun rays reach to the Earth's surface? Simply. So, clear sky, if there is a clear sky, the maximum amount of sun rays will reach to the Earth's surface in spite of cloudless. So, if the next point, if the wavelength of the radiation is more than the radius of the obstructing particles such as a gas, then a scattering of radiation takes place. This question has arisen in UPSC. Here the question demands how the scattering happens above the air particles. So you can see if the wavelength of the radiation, mind it, if the wavelength of the radiation is more than the radius of the obstructing particle that means kya? Air molecules, then a scattering of radiation takes place. Question was कि when a scattering happens. So a scattering will happen when a wavelength of the radiation is more than the radius of the obstructing particle. Okay. Then next, if the wavelength is less than the obstructing particles, such as dust particles, then reflection takes place. So this is about the reflection and the scattering. How the scattering happens and the reflection happens, both concept has given. So it depends on the radius of the obstructing particle. ठीक है? Clear point. So if the wavelength of the radiation is more than the radius of the obstructing particle, a scattering will happen. Or if the wavelength is less than the obstructing particles, then the reflection will take place. Is it clear? So how the reflection and scattering will happen, that's the concept. Curiosity has also joined us. Okay, very nice. Come to the next. One more point here. Absorption of solar particles, absorption of solar radiation takes place if the obstructing particles happen to be water vapor, ozone molecules, carbon dioxide molecules, or clouds. That is the greenhouse effect. Most of the light received by Earth is a scattered light. Or which color is scattered maximum? That's the blue color. Why the blue color is scattered maximum? It's just because having a less wavelength or a low wavelength. Take, you can see there is a red and there is a blue or violet. So red having a maximum wavelength. Red having a maximum wavelength and minimum frequency. Minimum frequency. While the blue having a minimum wavelength and the maximum frequency. So you can see, so this one is the sun rays, or when the wavelength is minimum, you can see here when the wavelength is minimum, take, that will be reflects. Okay. Next is the albedo. First of all, you have to know what is albedo. So very simple concept is this. Ki the amount of sun rays or a heat received to the Earth's surface, and at that time the heat reflects back to the space by the Earth's surface, and the percentage between these two are called the albedo. Percentage between these two are called the albedo. So simply you can see the albedo of a surface is the proportion of sunlight that the surface can reflect back into a space. Like you see, 100 unit of heat coming from sun rays or coming from sun as a sun rays and received to the Earth's surface. Okay. And at that time, the heat comes and direct reflects by the surface into a space region. Or like see कि 100 unit आया और 35 unit was returned to the space. Then what about the percentage between these two? 35, 100 cross 100, that is the 35%. Average albedo of Earth's surface is 30 to 35%. You can write down. Average albedo of Earth's surface. Average albedo of Earth's surface. It would be different for different surface. Like you can see a forest covered region or a water or a ice region where you will get maximum albedo. Okay, so next point is albedo of land is much greater than albedo of oceans and water bodies. The first point about this, albedo of land is much greater than albedo of oceans and water bodies. Why? Because the water bodies are transparent to the sun rays, and the sun rays penetrate into water body till 200 meter at least. So it has to warm 200 meter zone of the oceanic water. Okay, one more point here. Snow covered areas reflect up to 70 to 90% of insolation. Insolation in last class we have discussed. Like see, albedo. This effect is a change in the albedo, the fraction of the incident sunlight that is reflected back to space. What I said, कि the heat comes from the sun to the Earth's surface and it is directly reflected back to the space by the Earth's surface, or the percentage between these two are called the albedo. The albedo is much higher for a snow and than for water or a vegetations. Than for water or vegetations. Like you see in this figure, sun rays comes to this portion and it reflects back by the ice covered. Like you see, it will directly reflect back to the space. This one is 90%. The maximum albedo by any surface is by fresh ice. Fresh ice having a maximum albedo, that is the 90 to 95%. Even you can mention a 95%. Dirty ice will having a 90%. So the snow and ice covered water, because it constitutes a ice crystals. So it will reflect maximum amount of heat. While you can see in the water body, the sun rays penetrates into oceanic water till the 200 meter of depth. So it reflects very least amount of sun energy, and that is the 6%. That is the 6%. Like we take a example of forest. Example of forest. So the forest covered region will do albedo around a 15% only. Forest covered region will do albedo of around 15% only, and it absorbs most of the sun energy, and that is the 85% of sun's energy is absorbed in those regions, and that is a forest covered region. Okay, is it clear? Is it clear or not? Do you understand what is albedo? So, in other sentence you can see it is percentage between heat received by earth from sun and heat reflected back to space by earth's surface. Simply, what I said, it is percentage between heat received by earth's surface from sun and heat reflected back to space by the earth's surface. Very easy. Okay. Next one is the land sea differential. How it works and controls and affects the temperature over the distribution of temperature over the earth's surface. So now again we see the specific heat of water is 2.5 times higher than the land mass. Therefore, water takes longer to get heated up and to cool down. Just because of the specific heat capacity of water is higher than the land surface, so it will gradually cools down and heated up. That's why, and also because what I state, key water bodies are transparent for the sun rays. Sun rays will penetrate till the 200 meter of the depth of ocean or a water body, while the land areas are an opaque body. You see, like this. Here it is water body. So which one will warm fastly? Simply go for the concept, rest will remain with you. So this one is the opaque body of Pardarshi, opaque body, and the sun rays coming to this part. So it will heated the only the very thin thickness of this region or upper layer of this region. So it will warm fast. Okay, and then because of the conduction process, the air surrounding it also get heated. While you can see in the oceanic region or a water body, the sun rays penetrates into water body till depth of 200 meter. That means it has to warm 200 meter depth of water. So it will warm very gradually, very slowly. Getting a point? It will warm very slowly. So this region will become the zone of low pressure in the daytime, and while this region will become the high pressure zone. Okay. And we will discuss it again in further lecture, how the winds blows from the high pressure to low pressure. But here we can see the land and the oceanic or a water body differential heating process. Okay. Again the next point. average penetration of sunlight is more in water. What I said, up to 200 meters than in land, where it is up to 1 meter or less. Okay, that means what I said, which is written here. Therefore, land cools or becomes hot more rapidly compared to oceans. What I said in this picture, this one is the opaque body, here it is the transparent body. This one is the transparent body. So, just because of the opaque body, the sun rays has to warm only the thin layer of upper part of the surface. And in the water body, you can see it has to warm the 200 meter depth of water. Who will warm fastly or hot fastly? Exactly this one, land area. Okay, land area will warm fastly and the water body will gradually warm. Okay. In the last point, in oceans, continuous convection cycle helps in heat exchange between layers, keeping diurnal and annual temperature ranges. Annual temperature ranges. So, one more concept I am giving to you, like see. This one is the oceanic body. In the one side, you can see this part getting the maximum temperature is just because of the equatorial region. Getting a point? This one is equatorial region facing maximum heat, and this region will become the low pressure zone, while some other region of the oceanic body becomes a high pressure or a subtropical zone. Because of the some less amount of heat receives in this region. So this one becomes a warm, and just because of the low pressure created at this region, the sea level will raise here. What you see, sea level is raised here, and the winds blowing above and also the earth rotating on its axis, and so this part of water will move to this place, and the starting of currents. So what is currents? The actual transportation of water from this side to this side. Actual transportation of water from one place to another place, that is so called the current. This one is called current. But when this side of water is moving from this way, so because of the upwelling process, you can see here, cold water of lower region of that area will move upwards by the upwelling process. Here we are seeing the upwelling process happens, and the lower region, cold water will move upwards. Cold water is moving upwards, and this one is the convective currents. This one is called what? A convective currents. This is so called the convective. So once you are seeing there is a current or a hot current. This one is a hot current or a warm current flowing from this way to another place, or this side the maximum water is accumulated. Or in this side, you can see again the convective currents in a downwards. In a convective currents in a downwards, and now this current is moving from this way to that place. So that is the convective circulation in the inner part of oceanic body. Some place you can see the upwelling through the cold water is reaching to the earth's surface, and from just because of the maximum heat and the low pressure has created on this region, this part of water is moving towards this place, and the actual transportation of water from one place to another place, that is so called the current. So the currents is flowing from this part to that part, Here it is, that is the maximum accumulation of water, and this water is descending as a convective currents again here. So here it is the downwelling. Upwelling process in which the cold water reaches to the earth's surface. Upwelling is a process in which the cold water reaches to the earth's surface, or a cold water of the lower region. Cold water of the lower region reaches to the earth's surface through the convective process. So this is so called the continuous convection cycle. Continuous convection cycles helps in exchange between layers, keeping diurnal and annual temperature ranges. Okay. Next one is prevailing winds. It also impacts the differential heating of land surface. How? See, prevailing winds. Winds transfer heat from one latitude to another. Examples, if a winds comes from the poles, it is cold, or it will cools down where it will go. So poles would have been much colder if it is not for the moderating effect by the atmospheric circulation. Winds also help in exchange of heat between land and water bodies, that is the land breeze and the sea breeze. Land breeze and the sea breeze. Like we have just seen a part. Here you can see कि high pressure has created over the oceanic surface and low pressure has created above the land surface. And the winds blows from high pressure to low pressure. Now you can see here, that is the winds. Winds blows from high pressure to low pressure, and it blows at a daytime. It blows at a daytime. So this one is called what? Sea breeze, because it comes from sea. So here you can mention the sea breeze. And vice versa, in the night time, you can see the land area, just because of the maximum terrestrial radiation, becomes cools, and this region having a minimum temperature will receive, and it will become a high pressure zone. While you can see the oceanic water body having a differentiation of only the 1 degree Celsius of the temperature between the days and the night. Take difference between the days and night temperature is the only 1 degree Celsius above the oceanic water or water bodies. So in daytime, if it 27 degrees Celsius, at night time it will become the 26 degrees Celsius. While you can see in the land region, in the daytime, the temperature becomes the 45 degrees Celsius, and in the night time, temperature becomes the 70 degrees Celsius. Okay, it happens on the land or a water body. Now we are coming for the aspects of slope. What do you think about the slope? How the slope will impact over the differential heating of temperature? Okay, the direction and the steepness of the slope control the amount of solar radiation received locally. Simple point. The direction and the steepness of the slope control the amount of solar radiation received locally. Slopes more exposed to the sun receive more solar radiation than those away from the sun's direction. अगर हिमालय की बात करें तो हिमालय का नॉर्थ साइड है और साउथ साइड. So south side of Himalaya receive the maximum temperature because the sun rays can be reached to the only the south region of the Himalaya, not the north region of Himalaya. देखिए कैसे, like you see, here it is the Himalaya, and the direct rays of the sun in between the 23.5 degree north and south degree, like this. So you see here, the south side of Himalaya receives the heat only. not the north side of Himalaya, of the China side. Vivek, sir, North Atlantic drift raises the temperature in coastal areas of northwestern Europe. Yeah, obviously North Atlantic drift is अगर इसको कहें तो it is so called the blanket of Europe. Why it is considered as a blanket of Europe? Because it warms the coastal areas of the northwestern Europe. Very nice. बहुत बढ़िया विवेक. रेमचंद जी का बहुत बहुत स्वागत है. Okay, so again in next picture you can see here it is the sun and it will move northwards or southwards. It will move northwards or southwards, and this is the two mountainous region. Now you can see if suppose this one is the Himalaya, suppose this is Himalaya, so the southern part is this and the northern part is this. If we suppose a Himalaya, okay, then you see the southern part of Himalaya receive the sunlight while the northern part doesn't receive the sunlight. So if the northern part doesn't receive the sunlight, you can see the no sunlight, no crops, no human settlements, abundant moisture, forest only. Or if we see this side or a south side of Himalaya having received the sunlight, this will abundant sunlight, little moisture in soil due to intense heat, good crops, human settlement. इससे भी क्वेश्चन बनते हैं, ध्यान रखिएगा माउंटेन के संदर्भ में कि if the south side of mountainous region receives the sun rays, what kind of settlement and the crops and the soil is there. Even I can suggest you to go for the snow line also. Okay. So that is the point here about the aspect of slopes. Okay, aspect of slopes. Come. Next one is the ocean currents. We have already discussed. Ocean currents influence the temperature of adjacent land areas. Vivek has just asked one question that is all about the North Atlantic drift. Okay. So, for example, UK, considering its latitudinal location, has a relatively moderate climate due to the warm North Atlantic drift, just mentioned by the Vivek Kumar. And now you can see we have also given this point. North Atlantic drift having three phases: the Norwegian, Rannell, and the Irminger. And these three will warm up the northwestern coastal regions of Europe. And so this one is so called the blanket of Europe. This one is so called the blanket of Europe. Okay, blanket of Europe. If these current weren't present in that region, the whole area will become icy in a winter season. There can't be happening of trade and transportation. Okay. Now we are coming for the next, and that is the altitude. Altitude is very common. Key regarding the altitude, whenever we are going upwards through the altitude, through the height, so temperature decreases. Temperature decreases with increasing altitude. We have already mentioned in the troposphere. Here we can see that with increase in height, pressure falls, the effect of greenhouse gases decreases, and hence temperature decreases, applicable only to troposphere. So what I said, applicable only to troposphere. Okay. So that is all about the altitude. Next one is Earth's distance from Sun. Earth's distance from Sun. We know Earth revolves around the Sun and it has to follow the elliptical path in which you can see the Earth comes closer to the Sun and Earth gone far away to the Sun. It happens with 2 days. Let's see. In this picture you can see here it is the Sun and this one is Earth. And Earth revolves around the Sun. Okay. When it comes closer to the Sun, it's having a nearest distance. So here you can show nearest distance, and that is the 14.7 crore kilometer. You can see it here in a million or a million miles also. So when the Earth comes closer to the Sun, the maximum heat will receive on the Earth's surface. Because the shorter the distance, maximum the heat received by the Earth from Sun, and that is given in the second law of thermodynamics. Second law of thermodynamics explains shorter the heat, shorter the length, maximum the heat. So maximum heat will receive on south hemisphere. You see in this picture, maximum heat will receive on south hemisphere at this place, or it happens on 3rd Jan. Kab? 3 January, 3rd Jan. While when Earth gone far away to the Sun, that is the 15.2 crore kilometer. The distance is 15.2 crore kilometer, and this one is farthest distance. Date is 4th July, and this condition is called aphelion, and this condition is called perihelion. When Earth comes closer to the Sun, condition is called perihelion. When Earth gone farthest to the Sun, it is so called aphelion. So aphelion and perihelion is this. Take aphelion and perihelion. Now we are coming for the temperature anomaly. Now we are coming for the temperature anomaly. What is it? जिसको कि हिंदी में हम लोग तापीय विसंगति कहते हैं. Temperature anomaly. Let's see. Like you can see, here it is globe, and this is the 15° north latitude. So in January, in July, there is a temperature of this latitudinal area. Okay. So you see, at 15° north latitude, in July, the temperature would be 40 degrees Celsius. Temperature would be 40 degrees Celsius. But somehow, a place of this region, or latitudinal region, having a more than temperature of to this 40 degrees Celsius or less than temperature of 40 degrees Celsius. And that is so called the temperature anomaly. What is it? Have a look. The difference between the mean temperature of a place and the mean temperature of its parallel, that is the latitude, is called the temperature anomaly. Thermal anomaly, both are same. It is also called the thermal anomaly. Okay. So what is thermal anomaly? Like Delhi is situated on 28° north latitude, or in July there would be a temperature of 40 degrees Celsius. But at recent scenario, we see the maximum temperature occurs in Delhi and it is around 48 degrees Celsius. So it is +8 degrees Celsius. That is the positive anomaly. That is the positive anomaly. Okay. So the point is about the temperature anomaly or a thermal anomaly. The difference between it is the difference between the mean temperature of a place and the mean temperature of its parallel latitude. Okay, Mradul? It's called the temperature anomaly or a thermal anomaly. Here it is, thermal anomaly. The largest anomalies occur in the northern hemisphere and the smallest in the southern hemisphere. Why? It's just because of land and water body differential reason. Land and water body differential reason creates the largest anomalies occur in northern hemisphere and the smallest in the southern hemisphere. Largest anomalies occur on the land area, smallest anomalies occurs on the oceanic water. Okay, so this is all about the thermal anomaly or a temperature anomaly. Now we are coming for the air pressure. Air pressure, the most important topic where every year questions arises from this topic. Air pressure. For any exams, this one is most important because the questions settled with the barometer, with the doldrums, ITCZ and the horse latitude, even a measurement of the barometer also. Let's see. What is air pressure? So firstly, we will take some concept. This one is the area and a column of air is coming down. Firstly, you see the pressure. What do you think the pressure? What is pressure? Let's see. This surface is heated by sun rays. It will become warm. It will become warm. Basically, if you are standing or if you are sitting on a room or a land area or a nearby to the lake, there is a pressure putting down by the air over you. So that is the weight of air in a column which is putting pressure on your body. That is so called the atmospheric pressure. We will come for roaring 40s Nikki in next class. We will discuss it on westerlies winds. Nikki Sharma. Okay. So, what is air pressure simply? So, you can mention the weight of column of air very easily. Weight of column of air is called air pressure. Weight of column of air is called air pressure. How it occurs? Have a look. So here we are seeing the sun rays reaches to the earth's surface. The surface will become warm. Now the surface is heated. When the surface is heated through the conduction process, the area surrounding area will also heat it. Okay, now the air becomes warm. Now the air becomes warm, and when the air becomes warm, it will become lighter. And then it will spreads. So it spreads above. That's why the pressure releases above this surface. So the pressure releases above this surface. So here that is a low pressure has created. So low pressure creates when the temperature is high. Temperature high, there is a low pressure. If you see the temperature is low, surface becomes cools and the cold air becomes heavier. Cold air becomes heavier and due to gravitational force it will move down, and now it is coming down. So also it is coming in a column. So weight of column of air is called air pressure, and it increases the air pressure in this side, and this will become a high pressure. Okay, this will become the high pressure. So the high pressure when the low temperature is there, and the low pressure where the high temperature is there. Okay, let's see in the points. Atmospheric pressure is the weight of the column of air at any given place and a time. किसी भी स्थान और समय पर जो एयर का प्रेशर आपके ऊपर पड़ रहा है वही है एयर प्रेशर. वो हमेशा होता है, रूम में भी होगा, नदी किनारे भी होगा, झील में भी होगा. This amount of pressure is exerted by the atmosphere at sea level on all animals, plants, rocks, etc. Okay. So, what about the instrument by which we can measure the air pressure? That is so called the Android barometer. Here we have given the barometer, but we should write down Android barometer. Nirdram, Android barometer. So by which instrument we can measure the air pressure? That is the Android barometer. The atmosphere exerts a pressure of 1034 gram per square centimeter at sea level. One more point. Here you can write down like this: air pressure at sea level. And that is the 1034 gram per square centimeter, the first one. Then 1013.25 millibar MB, that is the millibar, or it is 14.7 pound per square inch also. So this one is the atmospheric pressure above the sea level. The question can demand any of these. Is it clear? Niki, Mradul, Vivek. Next. These pressure belts are not permanent in nature. Now we can see there is a air pressure belt over the Earth's surface on the globe. You can see the permanent region. But that is also the pressure belt is shifting with the shifting of the location of the sun. And also it will impact over the permanent winds. Okay. So next we are coming for the pressure belt. So these pressure belts are not permanent in nature. They oscillate with the apparent movement of the sun. That means the pressure belt is shifting with the shifting of the sun's location, and that's the point here. In the northern hemisphere, in winter, they move southwards, and in the summer, northwards. That means कि when the sun moves towards the north in summer, then the pressure belt will shift northwards. And in winter, when the sun going downwards or southwards, the pressure belt will also shift downwards. Okay. Now we are coming for the some pressure belt you can see here. The first one is equatorial low pressure doldrums, doldrum region. Is it visible or not? Is it visible? Okay. In between 5 degree north to 5 degrees south, there is a pressure belt, namely equatorial low pressure belt. Okay. Again, you can see 30 degree north to 35 degree north, there is a pressure belt that is so-called the subtropical high pressure belt, namely horse latitude. 60 degree to 65 degree north latitude, and also it is happened with the southern hemisphere. So this one is subpolar low pressure belt. So here it is subpolar low pressure belt, subtropical high pressure belt, equatorial low pressure belt. And in between the 80° north or 90° north, there is a polar high pressure belt. This one is so called what? Polar high pressure belt. Polar high pressure belt. So the atmospheric pressure belt happens above the Earth's surface with two factors mainly. That is the dynamic factors or a thermal factors. So the factors controlling the pressure systems, here we are going to see. The first one is, there are two main causes. The first one is thermal and the dynamic for the pressure differences resulting in high and low pressure systems. Pressure differences resulting in high and low pressure system. So what about those factors? We are going to have a look. The first one is thermal factors. What we have just discussed, maximum the temperature, lower the pressure, lower the temperature, maximum the pressure. So there is a three belt made up through the thermal factors. One is the equatorial low pressure belt and another two is the north pole and the south pole high pressure belt. So these three belt forms above the Earth's surface is just because of the temperature variations. Take temperature variations. So the thermal factors, when air is heated, it expands and hence its density decreases. Air will warm through the conduction process just because of the surface is heated and it will expand. The volume will increase and then the density will decrease, so the low pressure is there. This naturally leads to the low pressure. On the contrary, cooling results in contraction. This increases the density and thus leads to the high pressure. What we have discussed in this figure, we are seeing here that air is cold. When the air is cold, the contraction will start and it will increase the density. And when the density increase of the air, it will move what? The high pressure. This will form the high pressure. Okay, so formation of equatorial low and polar highs are examples of the thermal lows and the thermal highs respectively. So sometimes a questions arise in a sentence like ki equatorial low pressure in spite of thermal low pressure. Okay, so both of words you have to remember, thermal high and thermal low. Thermal high is the equatorial low and thermal low is the polar low. ध्यान रखिएगा. One more point about the dynamic factors. गतिक प्रक्रिया यहाँ पर बेसिकली होता है. Earth is rotating on its axis and just because of the rotation there is a formation of a Coriolis force and it affects the pressure belt. Also you can see the dynamic process affected by the increasing and decreasing of radius from one place to another place. Very important concept is this. The first one is, apart from variations of temperature, the formation of pressure belts may be explained by dynamic controls arising out of pressure gradient forces and rotation of the earth. Mark it. Dynamic factors, apart from variations of the temperature, the formation of pressure belts may be explained by dynamic controls arising out of pressure gradient, forces and the rotation of the earth, Coriolis forces. What I said, the earth is rotating on its axis and so there is a force against it, applying against it, and that is so called the Coriolis force. This one is Coriolis force. That is the deflection force. That is the deflection force or a Coriolis force. Coriolis was the person who has discovered this force, and so the name given the Coriolis force. So just because of the Coriolis force and the pressure gradient force, the dynamic factors controls the atmospheric pressure. Next, the formation of subtropical high pressure and subpolar low pressure belts are due to the dynamic factors like pressure gradient forces, apparent movement of sun and rotation of the earth. So it is directly impacted by the pressure gradient forces, apparent movement of sun and the rotation of the earth, that is the Coriolis force. So these are the thermal and the dynamic factors who control the atmospheric pressure belt. Okay. And that's why we can see a 7 atmospheric pressure belt above the Earth's surface. On a globe, you can see here. So this is the zone of equatorial low pressure, where the maximum heat trapped by the Earth's surface, and this is the zone of low pressure because of the high temperature. So this is the zone of the low pressure. Here air rises above and cools down on the upper layer of troposphere, and then because of the rotation of the earth, it gone towards north or south. And just because of getting colder, it will move downwards. It will move downwards at 30 to 35 degrees north or south latitude. That is the subtropical high pressure zone. That is the subtropical high pressure zone. When it comes down, it will divide or bifurcates into two parts. One will move into northern side, another will move into southern side, and that's it creates a cycle here. So the rising air and the subsidence air makes a cycle here, and this cycle is called what? The first one is called a Hadley cell. The one number is called Hadley cell. So Hadley cell is present between the equatorial low pressure and the subtropical high pressure belt. Questions can demand it is situated between which two pressure belt? A Hadley cell. So Hadley cell is situated between equatorial low pressure and the subtropical high pressure belt. Again we are saying the Ferrel cell, these waves or these winds moving towards the poles, and also from poles there is a cold winds are coming towards this side, and when these two winds collides with each other, just because of this westerly winds, which is the warmer, it becomes a lighter also, it will move upwards, and it will move upwards, becomes gradually cools down, and again it will bifurcate into two parts, and it will having a subsidence into this region, that is the 30-35 degree subtropical region. It will create again a cycle, that is so called the Ferrel cell. So Ferrel cell is in between the subtropical high pressure belt to subpolar low pressure belt, and here we are seeing at this side air rises above, but this side air subsides in a polar zone because of the cold temperature, because of the heavier air is there, density is high there, and it is creates again a third cell of the globe, and that is so called the polar cell. That is so called the polar cell. So now we are seeing here there are 7 air pressure belts and in between these belts there are what? 3 cell and a tricellular circulation in between these pressure belts are happening over the Earth's surface. Okay. So equatorial low pressure belt, subtropical high pressure belt, polar low pressure belt, subpolar, sorry, यहाँ पर होना चाहिए subpolar basically, or the polar high. So the pressure belts and the circulation cells is here. Okay. Now we are going for one by one. We will take an air pressure belt zone, that is the equatorial low pressure belt, the subtropical, the subpolar and the polar high pressure belt. What kind of questions can be arise from these sections? So what do you think about the equatorial low pressure belt first of all? Let's see. Equatorial low pressure belts. What kind of questions can be arise from this part? It lies between 10 degree north and 10 degree south latitude. Width may vary between 5 degree north and 5 degree south and 20 degree north to 20 degree south. I will just explain of shifting of pressure belts also. This belt happens to be the zone of convergence of trade winds from the two hemispheres from subtropical high pressure belts. This belt is also called the doldrums because of the extremely calm air movements. The position of the belt varies with the apparent movement of the sun. That is the shifting of the pressure belt. अब इसको जानकारी करते हैं तो हमने कुछ पॉइंट को जान लिया. देखिए, this is the zone of the generally 5 degree north to 5 degree south. In this region, full year, almost direct rays of the sun is just overhead at the Earth's surface. So, every day, the Earth becomes heated. So, now the surface is heated. When the surface is heated, the surrounding air will again warm by the conduction process. By which process the surrounding air of this surface will heat it, that is the conduction process. So through the conduction process, the air become warm. Now the air become warm, and when the air becomes warm, what will happen? It expands and the density will decrease. So now it expands like this and the air rises above the surface. Air rises above the surface and it will create a low pressure at this zone. Low pressure at this zone. Now we see from the 30 to 35 degree region, the trade winds is coming to this way. It's just because the air has uplifted in this region. The winds coming from another region, that is the high pressure zone, or a 30 to 35 degree region, subtropical high pressure, and this is the trade winds. This is the trade winds. It is warm. Now when the trade winds reaches to this region, it will be uplifted by the intense low pressure created as this region. Now the winds is moving upwards because whenever it will reach to the 5 degree north or 5 degree south latitude, it will be uplifted by the low pressure created at this region. And that is so called the convergence. And that is the convergence of these winds happening here. And that's why this region is called what? ITCZ. It's just because the equatorial low pressure is the intertropical zone in between the 23.5 degree north or south. It is the zone of 5 to 5 degree north or south. So that is the intertropical zone. And the convergence process is happening here. So this is properly called what? Intertropical convergence zone. It is so called what? Intertropical convergence zone. Now we are seeing here the coming horizontal winds has uplifted by the intense low pressure. So there is a lack of horizontal winds. There is a lack of horizontal winds, and this region becomes a very calm and stable. This will become a very calm zone, and that's why this region is referred as a doldrums. So one more point here. It is called doldrums. It is called doldrums. calm zone लिख के रखेंगे because of lack of horizontal winds. Because of lack of horizontal winds. अभी आपके घर में जितने बच्चे अभी अपने साथ जुड़े होंगे, जो बाद में भी देखेंगे, कई बार आपके घर में एक चर्चा होगी, आपकी माता जी बोलेंगे आज इतना गर्मी है कि एक भी पत्ता नहीं हिल रहा है। ऐसा होता है कि नहीं होता है? तो एक भी पत्ता नहीं हिल रहा है, दैट मींस द इंटेंस लो प्रेशर हैज क्रिएटेड एट दिस रीजन। आप ही के घर के ऊपर ITCZ है, सारी वायु जब ऊपर उठ रही है, अपलिफ्ट कर रही है, राइजेस एवं आप दिखा रहे हैं, तो निचले भाग में हाउ कैन द विंड्स ब्लोज? सो देयर इज अ लैक ऑफ हॉरिजॉन्टल विंड्स। तो पेड़ के पत्ते कैसे हिलेंगे? पेड़ के पत्ते हिलने ही नहीं। तो ऐसी गर्मी लगी जैसे कि एक भी पेड़ का पत्ता नहीं हिल रहा। समझ जाइए कि ITCZ आप ही घर के ऊपर आ चुका है। ठीक है, ITCZ आप ही घर के ऊपर है। सुमित तिवारी, मृदुल, विवेक, रोनित, निकी, got it or not? See, you all are from English medium. Have you ever attended a class in a totally in a English? Sumit, Mradul, Vivek, Ronit, Nikki.
राहुल, अरे यार मैम की क्लास में भी विश्व आ रहा।
ऐसा ही होता है विवेक कुमार कि आपके घर में इवन माता जी लोग तो बात ऐसी ही करती है ना, घर में तो बिहारी भी में ऐसी चर्चाएं होती रहती हैं कि आज इतना गर्मी है कि एक टोक पत्तो नहीं हिल रहा है। ऐसी ही होती है घर में चर्चाएं। सो दैट इज द ऑल अबाउट द ITCZ। तो ITCZ इज द डोल्ड्रम। ITCZ ही डोल्ड्रम है। डोल्ड्रम क्या है? इट इज अ काम जोन, एंड व्हाई इट बिकम्स अ काम जोन? बिकॉज ऑफ लैक ऑफ हॉरिजॉन्टल विंड्स। Because of lack of horizontal winds. Like you see here, there is a ITCZ in summer, you can see here, or ITCZ is here. Here it is the equatorial region, equator, which passes above the Amazon basin. But in this picture, you can see the ITCZ in summer is here. It has shifted towards the north. Vivek Kumar in bilingual. Okay. Actually, what? We are also providing classes in bilingual manner, but this channel has totally settled for the English medium. So we are also trying our best to give lectures in totally in English medium. और बट वन मोर थिंग आई वुड सजेस्ट यू कि जैसे आप पूरे जब भी कोई प्रॉपर इंग्लिश मीडियम में कोचिंग में जाते हैं ना, तो जो टीचर रहेंगे वो आपको एक भी शब्द हिंदी में प्रयोग नहीं करेंगे, क्योंकि उन्होंने इंग्लिश मीडियम से तैयारी की होती है, इंग्लिश तो अच्छी आती है उन लोगों को। और कोई अगर आपको मेंस इंटरव्यू तक अगर उसमें से गया होता है तो और अच्छी बात होती है, अच्छे नॉलेज उनके होते हैं, अच्छा आपको कंसेप्ट समझ में आता है। तो कोशिश मेरी होगी कि इस चैनल पर भी हम लोग उन बच्चों को भी टारगेट कर सके जो पूरी तरह से इंग्लिश मीडियम में ही पढ़ना चाहते हैं, समझना चाहते हैं चीजों को। और मैं आपसे जरूर कहना चाहूंगा जितने बच्चे अभी जुड़े हुए हैं कि सब लोग थोड़ा सा इंग्लिश को इम्प्रूव कीजिए, ठीक है। यू शुड बी गुड लिसनर। हाँ, फर्स्ट ऑफ ऑल यू शुड बी गुड लिसनर। आपको सुना हुआ समझ में आना चाहिए सबसे पहले तो, कि सामने वाला बोल क्या रहा है। इंटरव्यू में क्वेश्चन भी आपसे इंग्लिश में पूछे जाएंगे, हिंदी में क्वेश्चन नहीं होंगे। ओके, अब जैसे कल ही मैं तैयारी करवा रहा था, बीपीएससी के इंटरव्यू की तैयारी करवा रहा था, तो अब मैंने तो इंटरव्यू हिंदी मीडियम से अपीयर किया हुआ है, बट मैं इंग्लिश मीडियम वाले बच्चों को भी इतना है कि चला लेते हैं हम लोग आराम से। हमारे साथ जो और फ्रेंड लोग थे वो लोग तो प्रॉपर इंग्लिश मीडियम के थे जिनको मैंने कॉल किया हुआ था। तो बहुत अच्छा लगा कि उनमें से काफी बच्चे बहुत ही अच्छा इंग्लिश बोल पाए, बोला बिल्कुल कॉन्फिडेंस के साथ में। तो दैट्स द गुड थिंग, बहुत अच्छी बात है। और मुझे उम्मीद भी है कि उनमें से कुछ बच्चों का सिलेक्शन डेफिनेटली इस बार ही बीपीएससी में हो जाएगा, झारखंड पीएससी में हो जाएगा। सो नेक्स्ट विल बी यू। मेहनत कीजिए, बिल्कुल होगा, सक्षम होंगे। सो दैट इज एयर द शिफ्टिंग ऑफ प्रेशर बेल्ट्स, दिस वन इज सो कॉल्ड द एनआईटीसी। एनआईटीसी, नॉर्थ इंटरट्रॉपिकल कन्वर्जेंस, और इफ it will go down, this will called what? SITC, South Intertropical Convergence. ठीक है। So it happens because of the shifting of sun's location. Even ITCZ can be overhead at Indian Peninsular region till 30° north latitude. Till 30° north latitude. Okay. Now we are coming for the horse latitudes. Here it is. What is horse latitude? 30° north or south to 35° north or south. In this region, the trade wind subsides over the surface and it will create the high pressure. Whenever air comes down or air is subsidizing, the contraction will happen, density will increase, and also because of the frictions happens between the air molecules, the temperature will increase. Okay, temperature will increase. So it is the corresponding latitudes of the subtropical high pressure belts are called the horse latitude. In early days, the sailing vessels with cargo of horses found it difficult to sail under calm conditions of this high pressure belt. They used to throw horses into the sea when fodder ran out, hence the name horse latitude. I am giving an idea. Let's see. This is the zone of 30 to 35° north or south. In this region, trade winds are you see trade winds subsidizing at this region, and it comes in a cell. It comes in a cell. And in the earlier era, the trades happening with the sea route only. अब जैसे हम लोग यहाँ पर देखें कि इधर से ट्रेड विंड्स की स्थिति है, वेस्टर्लीज अपर ट्रोपोस्फेरिक सर्कुलेशन की हम लोग चर्चा दिखा रहे। कोल्ड विंड्स हम इसको समझ लेते जरा सा। इट इज द कोल्ड विंड्स। ये एक ठंडी पवन है अपर एटमॉस्फेरिक सर्कुलेशन के संदर्भ में, और ये ठंडी पवन नीचे आ रही। तो जब ये नीचे आएगी तो ये सेल में हाई प्रेशर बनाती है। याद रखिएगा, ये सेल में हाई प्रेशर बनाती है। ये आपको किसी बुक्स में लिखा नहीं मिलता है जल्दी, जो चीज मैं अभी आपको बता रहा हूं ध्यान दीजिएगा। ये सेल में हाई प्रेशर बनाती है। पुराने जमाने में जो व्यापार होते थे तो आपके सेलर के वेसल्स हमने देखा भी लिखा हुआ। तो वेसल्स जो होते हैं, बड़े बड़े जो कार्गो जहाज होते थे, उनमें व्यापार किसका होता था? हॉर्स का व्यापार होता था। ठीक है, घोड़ों का व्यापार होता था। अब ये हॉर्स laden vessels whenever comes down to this high pressure zone, तो ये हाई प्रेशर जोन जब इसके ऊपर आ जाएगा, ऑलरेडी हॉर्स पूरा भरा पड़ा है तो ये डूब सकता है ना। सो दे थ्रो आउट सम हॉर्सेस इनटू एन ओशन। यहां पर गए, फिर से इन हॉर्स को चढ़ा लिया, फिर इस भाग में गए, फिर से दे हैव टू थ्रो आउट सम हॉर्सेस टू डू बैलेंस द शिप। सो in this region they have to throw out the horses into an ocean at several times. So this region has name upon what? Horse latitude. So the horse latitude is in between the which two latitudinal part, that is 30 degree to 35 degree north. This is a dry zone. This is the dry zone. Okay, it's just because the air is in a descent mode, and whenever the air comes in a descent mode, it will having a contraction, and by the contraction the air will become warmer, density will increase, it will create the high pressure. Okay, so this region are called the horse latitude. Now you just remember these facts also. Okay, horse latitude के बारे में. Next one is the subpolar low pressure belt. How the subpolar low pressure belt creates? I am giving you an example. Like see, here a warm winds is coming to this place, and this one is westerlies. This one is westerlies winds, and through this side you see a cold winds is coming. That is the polar winds, comes from the poles, and this is comes from the subtropical high pressure belt. So the warm and the cold winds will collide here. This one is the warm. So the warm winds is the lighter one. So it will move upwards. It will move upwards, and it will create the what? A low pressure. It will create a what? A low pressure there. विवेक कुमार जी बिल्कुल सही बता रहे हैं. Yes, you said right. So in an equatorial low pressure zone, there is a lack of horizontal winds. That's why those regions are very calm zone, and that's why it is referred as the doldrum. Exactly, Vivek. And it is happening in recent time in a great northern plains basin also. Okay, you see, just because of the intense heating or a low pressure has generated over the Ganga basin, now you can see the most of the time air will rises above, and so जितने भी पेड़ पौधे होंगे, पत्ते होंगे, बिल्कुल शांत आपको देखने को मिले. वो आंधी तूफान आ जाए तो अलग चीज होता है, वो that will create the storms, that is another phenomenon. ठीक है. So here we are seeing the westerly winds coming from the subtropical high pressure, and the polar winds coming from the north pole or south pole region. And when these two winds collides, this one is lighter, so it will move upwards, and it will create the low pressure. Here it is. These are dynamically produced, and this is a dynamic process to the Coriolis force produced by rotation of the earth on its axis and ascent of air as a result of convergence of westerlies and the polar disturbance. आपके सामने सेम पॉइंट आ गया. जो चीज मैंने बताया सेम पॉइंट आपको यहां पर देखने को मिल रहा है. यहां whenever you will take the geography as an optional paper, so I will give you an idea more than this point, and that is all about the radius. That is all about the radius. Like see, the maximum radius is in at equator, right? And minimum radius is at poles. So, like see here, when we are going from equator towards the poles and we are reaching the 30-35 degree, the radius is decreased. Here you see the radius decreases, and the radius decreases and the cold winds will becomes heavier and gone down. While we are seeing for the 60 to 65 degrees Celsius, 60 to 65 degree north latitude, this region having a more radius than the polar region. So here the radius increases, here the radius decreases, and also the earth is moving on its axis, that's the rotating process. So this is the reason also to ascent of air and the descent of air. Here we are seeing the descent of air, and here we are seeing what? The ascent of air. सिंपली इसको ज्यादा एक बार समझ लेते हैं कि जनरली समझिएगा मैं जो बताना चाह रहा हूं आपको कि जब पोलर एरिया ध्रुवीय क्षेत्रों से आप उप ध्रुवीय क्षेत्रों सब पोलर की ओर आते हैं, पोलर से सब पोलर की ओर आते हैं, रेडियस बढ़ जाता है। तो रेडियस बढ़ गया तो एरिया बढ़ गया, एरिया बढ़ गया तो वायु ऊपर की ओर उठ जाती है। तो दैट इज द रीजन बिहाइंड। ध्यान रखिएगा, ये ऑप्शनल बेसिकली चलता है जो मैं आपको कंसेप्ट दे रहा हूँ, किसी किताब में भी आपको मिलेगा नहीं जो मैं पढ़ा रहा हूँ। तो ये पोलर एरिया से जब आप सब पोलर एरिया की ओर जाते हैं तो रेडियस बढ़ जाएगा, और ये गर्म और ठंडी वायु राशि आपस में आकर मिल रही, तो गर्म वायु राशि हल्की होगी, रेडियस बढ़ चुका है, पृथ्वी का सर्कुलेशन हो ही रहा है, रोटेशन हो रहा है, तो ये वायु अपलिफ्ट कर जाएगी, एसेंट आपको देखने को मिलेगी। वही चीज अगर हम लोग सब ट्रॉपिकल रीजन की ओर देखें तो यहां की तुलना में यहां पर रेडियस क्या हो जा रहा है? कम हो जा रहा है। अब रेडियस कम हो गया, ऊपरी भाग में कोल्ड एयर मौजूद है, दोनों तरफ की ठंडी अपर एटमॉस्फेरिक सर्कुलेशन आने वाली ठंडी वायु आपस में आकर मिल रही, तो और ज्यादा ठंडी हो गई, भारी हो गई, रेडियस कम हो गया, एरिया कम हो गया, वो वायु नीचे की ओर आ जाएगी, वो वायु नीचे की ओर आ जाएगी और इट विल creates a high pressure. So these two pressure belts are for the dynamically process. These two are made up by the dynamic process. Yeah, exactly, Vivek Kumar. Horizontal movement of air is not happening in a equatorial region, but there is a storms, there is a climate, there is a weather phenomena are also occurs. That is different thing. But in between the 5 to 5 degree north or south, you see it is a calm zone. Weather phenomena are different things. मौसमी परिघटना तो होंगे ही होंगे ना, बादल बनेंगे, वर्षा होगी, आंधी तूफान भी आएगा, उसमें हवाएं चलती देखने को, लेकिन जनरली वहां पर सालों भर ऐसा ही देखने को, जैसा कि अभी आप अपने एरियाज में बिहार यूपी के क्षेत्रों में देख रहे होंगे कि अभी मौसम शांत रहता है, या तो आंधी तूफान ही चलेगी, नहीं तो आप देखिए पेड़ पौधे के पत्ते नहीं हिल रहे होंगे। आप बाहर घर से निकलिए और अभी आप देखिए कि आपके घर के बाहर पेड़ पौधे के पत्ते बहुत ज्यादा ऐसे ऐसे हो रहे क्या? नहीं होंगे, क्योंकि देयर इज अ लो प्रेशर। ये लो प्रेशर है ना, कहां से हिलेगा बताओ जरा सा? जब वायु ऊपर उठ रही है तो पत्ते कैसे हिलेंगे? गेटिंग अ पॉइंट? विवेक, आफ्ताब, मृदुल, सुमित, and the last, the polar high pressure belt. Polar high pressure belt 80 to 90 degree north or south, both you can mention in a single picture. And this is the zone, very cold region, cold surface. So air becomes cold and it will go on downwards. It will create a high pressure there. This is also the dry zone. dry zone. Moisture around 0% is present in this region. Okay. So that is the air pressure belt we have discussed today. Or in next class, we will discuss the winds, and then we will move to the cyclone. We give you the idea about the clouds. Clouds के भी formation से और उस clouds के type से questions आ जाते हैं, वो भी मैं आपको करवा दूंगा. और then the fronts, winds is the most important topic, उसको ही करवा देता हूँ. यहाँ तक क्लियर है? कोई डाउट तो नहीं है किसी को? Main cheese is the concept which you have to acquire, which will be used in your examination center. कंसेप्ट पर सभी को फोकस करने की जरूरत है, ध्यान रखिएगा, आप बिल्कुल कर सकते हैं. ओके, सो आज की क्लास को यहीं तक रखते हैं. और ये जो पीडीएफ है, पता नहीं पीडीएफ आप लोग को अवेलेबल हो रहा है या नहीं हो रहा है. आई विल कंसर्न विद द मैनेजमेंट and then provide my last 3 classes PDF to post on the example official application. If you want our PDF, then you have to move to the example official application where you can get the PDF of all classes. ठीक है? So that's all about the today's class. We will meet you in next week. So till then, be happy, be cool, and keep rocking, keep a study tight. Meet you soon. Thank you.